All right. Okay. So yeah, here's the schedule for next week in case I forget who I tell and who I don't. Mondays, no longer the CMAS. It's just a regular Monday, like any other Monday. That's a good band name. Any other Monday. Ooh, I'm gonna steal that. I like that. I was looking for good band names. And then, so that's the only day that everybody's in school. Okay. Then, at most, you come one other time next week. Okay. Juniors, you are only here in addition to Monday on Tuesday. Sophomores Wednesday. If we have freshmen here, it'd be Thursday. Seniors, not at all. Okay, so seniors, you are only here on Monday. You come in the morning to take your test for whichever, we're going 11, 10, 9. It starts at 7:40. Okay, your classroom door locks and is now closed at 7:40. If you show up at 7:41, you know, the train has left the station at that point and you missed it. Okay, do not be late. You know what that light can be like sometimes, what it's like to get into school. Now, I mean, you'll only have just juniors, just sophomores, or just freshmen coming in, so maybe it won't be as crazy. But be early, okay? Be early on those days. And expect, you know, to kind of settle in for the morning. So bring something to drink, bring a little snack. If you're not like a breakfast in the morning kind of person, sometimes, you know, people just kind of wake up and go. I totally get that. I'm not really hungry, you know, after I wake up right away. But come prepared because there are breaks that are scheduled in for your tests where you can snack a little bit. But then you go home. Okay, Tuesday, Wednesday, Thursday, no classes in person. Everything's remote. Okay. So when we meet, which will be right here on Wednesday, from 1:30 to 1:55. Yeah. I don't have big plans for that day. Let's just say that in terms of what we're going to get done. Yes, sir. Yes. No, you go home and you attend remotely. Yeah, so you take your test, go home because I know it says lunch. That's a teacher scheduled lunch. There is no food on any of those testing days. Okay, they're not doing nutrition services on those days. So you take your test whenever you're done. Whenever you're done, you go home, and then you log on remotely to whatever classes you have on that day. 1, 2, 3, 4, 5, 6, and then 7, 8 homeroom on Thursday. Then we have a nice 4-day weekend. Aiden, is that a question? Usually it's in the English hallway. I don't know that that's out yet. I know they just assigned teachers to their classrooms. I don't know if they've just assigned students yet. If I hear about it, I will let you know. I'd be happy to pull that up so you can see where you're at. But my expectation is certainly by Monday, but hopefully like tomorrow or Friday in the English hallway, they'll have those big posters with all the names, if not, of what room you're going to be in. Could be first floor or second floor. Doesn't necessarily have to be a classroom you've ever been in. It's usually alphabet. That's easy for us in terms of testing administration. We have a lot of things on our side to make sure it goes well. So hopefully we'll take care of you, right? So classes remotely each afternoon. Nutrition services closed, so plan ahead, bring a water and a snack. And transportation, make sure you can get to and from school at those times because the buses are going to run normal schedule. You know, like Sagewood gets out and then they come pick us up, or vice versa. You're not going to get on a bus at 12:30. Okay, you're going to get on a bus at like 3 o'clock if you take it. Okay, but if you have a ride or drive yourself, then you're good to go. Okay, we're off Friday, we're off Monday, and then we'll get back after it on. Cool, sweet. What I wanted to do today was give us a chance to practice some stuff. So I called it homework 3.2, but we're just going to do it right now. Pages 194 and 195 in those guided notes. I hope we can get it done during class. Maybe you have 1 or 2 to finish up later. Almost exclusively quotient rule, except number 2 is the product rule, because it's just tangent times sine. But what you'll see with these questions here, Page 194 takes us that much further, right? Find the equation of the tangent line at a certain x value. Number 2, find the equation of the tangent line at a certain theta. Number 3, find the slope of the normal line. So, find the slope of the tangent line, then we'll go perpendicular. And then 4, 5, 6, and 7 are just straight derivatives, okay? So what I'll do, of course, you guys do your thing. You can put some headphones in, tune out the world. You can talk together. We can work stuff out as a team, whatever works for you. I'm going to work through number 1. I'll stop. I'll leave it up for anybody that has questions or wants to take a peek. Then I'll erase it, work through number 2. Then I'll erase that, work through number 3. And then I'll probably do like 5 and 7, which I think were the trickiest ones on that set. So I'll get 5 of them done for sure in our 45 minutes that we have now, 40, right? So we're out of here at 55. So do them in whatever order you want. I'm going to go 1, 2, 3, 5, 7. Okay. And then put it up on campus. Cool. All right, away I go. Away you go. Here we go. U and V. Looks like quotient rule to me. I can't factor and simplify anything. I mean, I could pull out the x, but that's not going to do me much good. Thank you. He is. So page 194 and 195. Yeah, we're just going to do it right now. Homework 3.2 it's called. So put it on canvas when you're done. Do you? I think we could probably all agree with that statement. I think like out of everything. Right, I know. Out of here with that. Boy. Yeah. Prime. Video minus V. I think this one ends up just kind of pretty straightforward. Just kind of set it up, expand, simplify, and then we're done. So it's a decent start. And we'll just plug in negative once. I guess. So I kind of like this one as the first one. Over. And again, I'm just going to leave the denominator. It's a polynomial, right? It's a binomial. So I'm just going to write it squared in the hopes that maybe I can simplify. And if I can't, then I didn't waste my time expanding something that doesn't need. All right. Expansion time. -9 plus 4, -5. Minus, and I'm going to get crazy. I'm going to distribute and do the negative part. I know. Wild man. -9, so plus 9. All right, so let's see. And I hope that quadratic's factorable, but that's the 4 multiplies the -18. 118, 2 and 9, 3 and 6. No, that's it. That's my derivative as best as I could. And if it just said find the derivative, I'd be done. But they want the entire equation of the tangent line. So I'm going to need g is -1 and g. And this evaluating, once you get there, I know I might be ahead of where you're at right now, but that can all happen in calculus. Your table can do all of that arithmetic for you if you want. Or you can do it by hand, showing as much or as little work as you want. I like the challenge of doing it in my head, so I'm just going to try to evaluate the top and bottom of each fraction separately, and then I'll simplify them. So plug in -1 into g. 2 plus 3 is 5. -3 plus 1 is -2. So -5 halves. Put the negative out front. It's a number, the value is negative, so that negative doesn't stay on the bottom. Or -2.5. That's cool. You can use decimal. Do not use mixed numbers. 2.5 don't ever really. And then into the derivative. Let's see. 6 minus 4 is 2. Minus 3 negative. That sounds like me. Yeah. My son has medication for his heart, and that's the form of his tongue. He's good. He just needs it. Otherwise, it's like over. Plug in -1 down the bottom. And leaving a factor makes the evaluating easier too. So I don't have 9x squared plus 6x plus 1. I just have to plug it in once. So twice, -1 is 3, -2, 4. -1, 4. So 5 plus 5. So -1/4 x. Voila.
Why did you make that one a positive?
Because y minus y1 and x minus x1, yeah. Point slope looks like this.
Oh, yeah.
And so if I'm subtracting a negative, I might as well just write the positive instead. Yeah. Now you can always use slope intercept, but that's just more work. So I hope you use point slope. It's definitely the most efficient way to write an accepted version. But sure, like distribute the -4, the -1/4, and add the 5/2. It just gets messy. That's a good start. I like that. 2's fun, 3's fun, 5's fun. 7 is a handful for sure. So much so I'll probably need this board to finish 7. So you get to 7, right? But let's do 2. I'll leave that up there for another second. I'll put my wall. Now I'll come back and I'll keep rolling on. And of course, ask questions if you need to.
For 2, u is tangent of theta. So what would you use? Because I know I was just thinking that. Would it be sine? I don't know. Oh, I think, yeah, wait. Oh, yeah.
Anything about number 1 you need clarification on, questions before I erase it and get after the next one? All good, folks at home? That's my 2 hats look really good. I think it's nice. I wonder if I could fit it. This might be even better look. There we go. That's better. That feels more natural. Let's do it. Wonder why I have a headache. This is so weird. All right. 2's kind of crazy, only because like it's in this quotient rule section, but there's no fraction. I guess I could. No, don't write this because I don't know that this is going to help us. Like I could write sine as or tangent as sine over cosine, and then all right. So this would be like sine squared over cosine. But here's the problem. We do not know how to find that derivative because that is sine squared, right? It's not algebraic. So the power rule does not come into play there. I cannot just call that 2 sine. It's not. as much as I want it to be, you'll actually see why it's actually going to be 2 sine of theta times cosine. It's a composition of functions, right? You've got an inside function and then kind of like an outside function doing something to that. That's the next one. That'll be tomorrow and Friday. We'll play around with those kind of ideas. So I'm just going to use the product rule. Now we know the derivative of tangent, which is nice, in unison. That was well done. It's like we practiced that. Nice. Here we go. So product rule for number 2, which is good because it's been a little while since products. And now that we know the derivative of tangent, this won't be too bad. But you're going to see, I think, that trig is always just going to be harder for you than not, right? Than regular algebraic stuff. So the more we practice it, I think the better. Du secant squared. Now they want the whole tangent line too. So again, I got some stuff to do once I find the derivative. So I'll try to organize myself best I can. There's my setup. I don't know, I'll go this way. F prime of theta this time. That's just 1 prime right there. UdV times v du. dv. And I'm going to try to simplify as much as I can. We'll see how far it gets me. Plus v du. Product rule. UdV plus v du. Yeah. Yeah. Now you'll see after tomorrow and Friday, I could have called it sine squared over cosine squared and gone with the quotient rule, but up top that derivative takes just more knowledge than we have. But as much as like that is the derivative, I'm going to look for ways to write it simple. That's 4 different thetas I'd have to plug pi over 4 into. It's not wrong. Like that's the derivative. I could like leave it like that and I wouldn't be wrong. It's just if there's a way to simplify it, like I don't know, like calling everything sine and cosine, maybe something nice happens. We'll see. Because tangent, like we said before, that's sine over cosine times cosine plus, okay, sine. And then, I'll see. Does that help me? Let's see. Does that do anything for us? Question, yeah.
So you swapped the sides so you can make it addition up top. Is that the reason?
No, I am using the product rule, which is u dv plus v du. Because it's a product. There's no, like, look at the way that your function is set up is one function times another. Tangent times sine. So I know, like I was saying, like I know we're in like this quotient rule mindset, but that's not a fraction. It's a product. So I can apply whatever rule makes sense in that moment for whatever the function. Yeah. If it was a fraction, I would definitely do v du minus u dv. Yeah, all over v squared. But this one's just a product. So I think that's a little simple. Right? The formula is a little bit easier than the quotient rule. So like if I can use a power rule, I'm always going to do that. If I can use if I have to use a product rule and that's a good choice, then I'll use that one. If I'm stuck with the quotient rule, it's kind of my last choice out of all of them, just because it has the most going on. But hey, at least with this, I can get rid of cosine. That's kind of nice. That's something. All right, so the first term is just sine. That's better. I mean, there's nothing to simplify there with the second one. I mean, I could call it like 1 minus sine squared and have it all in terms of sine, but like then what? Nothing really. So I don't know if that's going to do me any good. I'm turning a monomial into a binomial. That sounds like more work than less. I don't think changing the second set of terms or second set of factors did anything for me. I don't know. So, like that's fine. Like sine of theta over cosine squared theta is not something I'm really excited about. Like putting that into one fraction, especially having to evaluate. I think I might just keep them separate and like go back to secant. I don't know. Like I don't think it did me much good. And not writing things as fractions is better than writing things as fractions in terms of simplifying. So I think that looks pretty good. But that's 3 different thetas, right? That's 3 different spots to plug some stuff in. Like simplest form, like in my mind with trig, just has like the fewest trig functions possible and the fewest thetas possible. So I don't have as much evaluating to do. So there is one other thing. Maybe. Fine. Hey, that's only 2 thetas instead of 3 of them. That's better. Good. Okay. And as much as that thing, that 1 plus secant squared looks really nice, like with Pythagorean theorem, Pythagorean identities, if you take a peek at that identity, it's actually secant squared minus 1, not secant squared plus 1. So that's kind of a bummer. I was really, really hoping that I could like rewrite that with the Pythagorean identity, but it's not going to work out. So I think that's my best F5. It's got the fewest trig functions. There's still 2 of them, and secant in my mind is just cosine, right? Just 1 over cosine. And there's only 2 thetas I'm gonna have to plug stuff into, so that's not too bad. But I think lots of different versions here are gonna work, and it's tricky to say like conclusively, like with all my heart, that one is the best. I like the last one better, but maybe you don't. And so I'm not gonna stress what final form of the derivative I need. But I'll just tell you the things that I'm hoping for. Fewest trig functions, fewest thetas. And if factoring helps you get there, then I'm okay with parentheses as part of that final. But if you left it in the first version in blue there and you didn't recognize simplifying, that's not wrong. As long as you can evaluate, that's a lot of evaluating to do. But if you can get to the right answer, I'm good with that. So we want the whole equation, so I got to do my f of pi over 4 and my f prime of pi over 4. I'm going to do f first, see what happens. But I actually have to like go through this process of evaluating tangents of pi over 4. Now, the calculator can do this. But with these angles that are in a quadrant somewhere, right? It's not a quadrantal angle at, 90, 180, 270, 360. I'm expecting something irrational. And so if you're going to use a calculator to evaluate here, then just round 3 decimal places. I'm going to go through the process of finding the exact right answer, and then I'll round just to make sure I got it right. Yeah. Is it noisy? Yeah. Okay. It's just warm. So. Thank you. But yes, I agree. It's a little noisy. So. All right. Ooh, tangent of pi over 4. Yay. That's 1. Sine over cosine at a 45 degrees. Same x and y value. Just have to watch my sign in the first quadrant, so everything's positive there. And then sine of pi over 4 is radical 2. So there's my y value, which, if you just plugged it in, would be 707. And I'm good with you using either one of those, radical 2 over 2 or 0.707. I'm going to use a radical 2 over 2 when I actually write this out. All right, now f prime. This one's more fun. Fun's not the right word, is it? Run for me. Sine of pi over 4 times 1 plus secant squared of pi over 4. Sine of pi over 4, that one we already did. That's radical 2. Okay, then 1 plus. Now, I'm not going to write all this out, but I am going to say it. Okay? Secant is 1 over cosine. So in my mind, I'm just going to worry about cosine, and then I'll flip it. So cosine of pi over 4, radical 2 over 2. Flip it. All right. 2 over radical. Right? There's secant of pi over 4, the flipped version of cosine. I don't know if we've done a lot of this, but If you rationalize that, multiplying by radical 2, top and bottom, you actually just end up with the square root of 2. Right? Multiply top and bottom by the square root of 2. The denominator just becomes 2. So this 2 and this 2 collectively cancel out. So I just get that. That would be secant of pi over 4. You cool with that? People at home are like, what are you talking about? I'm over here, sorry. Radical 2, radical 2. But I don't want secant. I want secant squared. So just 2. So I get, I hit myself, 3 radical 2 over 2. Which is, only because I did this about an hour and a half ago, 2.12. I definitely did not know that ahead of time. But it is just this times 3, which makes sense that 0.707 becomes 0.7 times 3 and 0.7 times 3, 21, 21. Oh, cool. Why am I doing all that? So I can write this. Y minus, again, I'm going to use the exact version because it's pretty simple. It wasn't too crazy. And then 3 radical 2 for my slope over 2 x. Not x. That is not the name of my x-axis. The name of my x-axis right now is theta. Okay, if your variable is theta, that is your x-axis. Right, that your independent variable is the name of the horizontal axis. There we go. Hopefully that sinks in okay for you. It's not easy. Best part, you can just type it in the calculator. Here's the issue though, there's no secant button. So here's how you would type it in. Sine of, I'll make it look like it's in the calculator. Pi over 4 times 1 plus, here comes the fun part, parentheses. Secant squared, so that's 1 over cosine of pi over 4. Close around pi over 4. Close around secant so I can square it and then close. Close, open, okay. Close, oh sorry, open, 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 close, close, close. That's what it looks like in red in your calculator. Because secant is just 1 over cosine, and I just can't put the squared. Like I'm just worried about like trying to put the square like here, like right after that. I close the parentheses around the 4, and I don't know, maybe I'm just worried for the wrong reasons, but I just don't want the calculator to square pi over 4. I want it to square 1 over cosine of pi over 4. And you should get 2.12. And that's why I did it by hand. That's why I just evaluated each piece, kind of thought that through so I can get the right answer. But if you type this in, you'll get there too. So I'll leave that up for another moment or two so you can go on that. Great question.
Yeah, so going back to above the line, sine of theta times secant squared of theta, how did that become 1 plus secant squared of theta?
Factored out the sign that was in common with both.
Okay.
So it's like x plus x times 5 is, well, yeah, x 1 plus 5. In my mind, x is sine. Right? It's in common with both. So I can factor it out. Well, I took everything from here, so I just have 1. And I took this from all of this, so I just have secant squared. I don't think that that step is necessary, crucial, but it did take me from 1, 2, 3 spots for me to plug in something for theta to just 1, 2, which was easier for me. And when I got down to here and I had like all this mess to mess around. So I saw common factors, so I factored it down, hoping that, hey, if something is like that's left inside, maybe that's like further factorable or further simplifiable. Like this is almost a Pythagorean identity for tangent. It's like this close. It just needs to be secant minus 1 or 1 minus secant. I don't have the right one. I couldn't use it, but at least took me down to 2 thetas in my derivative rather than 3, which in my mind is simpler. And it ended up being worthwhile, I think, when I evaluated the derivative at that spot and had to do sine of pi over 4 and then 1 over cosine squared of pi over 4. I had to do that. And I want to do that as seldom, right? As few of those evaluating. That makes sense? Yeah. So compare that. Factor it out here. 1 factor it out here. Yeah. Good. Let's talk it through again. Sure. Okay. So the thing that we need to remember about trying to evaluate this is that the only thing that helps us evaluate things exactly is a unit circle. And the unit circle is cosine for x, sine for y. So I'm going to think of it in terms of just sine and cosine instead. So really all I need to do is take cosine squared and then flip it. Take the reciprocal. But so what I'm going to do is find the cosine of pi over 4, square it, and flip it. So I can get secant, right? Or, and it's the same thing, I'm going to find cosine of pi over 4, flip it, and then square it. Same thing. So there's the cosine, right? I could square it right now, which is 2. Or I could simplify it right now by rationalizing and then square it. I should get there anyway. Like if you just square this right away, you get 4 over 2, which is.
Yeah, I've been confused about the 4 billion stuff.
This part?
Yeah, or no, like
here.
But I think,
yeah, secant is the reciprocal of cosine. So I figured the cosine that is. So that's why this number is 2. All right, I'm gonna do 3 because we're running short. I wanna get to 7. I might do 3 and then 7. This one's not too bad. This is normal line though. So you and me.
Rosie, can you move the camera back over?
I absolutely can. Thank you for letting me know. There you go.
Thank you.
You're welcome. Thank you for reminding me. Back to quotient rule. So video minus b du minus u dv. Put parentheses wherever you feel you need to. All over v squared. So I'm just going to put cosine squared. So 3 cos theta plus 3 theta sine theta all over cosine squared. That looks good. Okay, so that kind of ends my derivative conversation. Now I can actually drop it in. At prime of pi, I love when they pick quadrantal angles because now I'm hoping something disappears. 3 cosine of pi plus 3 pi sine of pi over cosine squared. All right, unit circle, pi is over there, so -3 plus 0. 3 times pi times all over cosine of pi, whatever that is, squared. So -1 squared, which is what? So -2. So if the slope of my tangent line is -3, that implies that the slope of my normal line is 1. Opposite. Slope of the normal line. I kind of like that last line of work just because it tells me you know exactly what the derivative was at that spot and then how to get the slope of the normal line from there by taking the reciprocal. So I love kind of getting in your head a little bit as to what you're thinking. Now that notation is up to you. Say it however you want, but I think it's important to say it. Now, maybe you just jump right to there. Maybe you're like, I know what the derivative is -3, which means the normal line is 1/3. So maybe you don't have to write that. You can just jump right to there. That's cool. But I like that style, M with a little NOR or NORM on the bottom. You just say the word slope of the normal line. There's really no better notation than that. Right, M and then subscript. As nasty as the trig stuff was with number 2, this one was actually kind of nice. It helped that we only had 1 trig function to start with, which means at most we only have 2 by the end. For the sake of time, since we're down to less than 10 minutes, I think I'm going to jump to number 7 and do that one. When you look at that second page, though, when you look at 195, this is just straight derivatives. So hopefully something like 4 is pretty nice. There's nothing to factor there at the beginning. So you're just going to jump right in, expand, simplify, see where it gets you. With number 5, v is definitely x to the 1/2 plus 1, like right away, rewriting the square root of x is x to the 1/2, and like holding on to those fractional exponents and negative exponents all the way through, right? Until the very end. So you're absolutely done. And then rewriting it, I think is going to be good. There is some messier kind of notation with that. I'll do this work, and we'll look at it tomorrow morning. I'll have all these done. I'll put the solutions up for us when we get to class tomorrow. So that if you did get stuck, if you have questions, we can get those answered before we move up. 6 kind of looks like 3. It's just flipped and it's got theta cubed there. But that one should work out nice. I think with 6, you'll have some common factors of theta kind of all over the place. So you'll be able to kind of pull some out and divide those away. That's cool. But I want to do 7. Okay, 7's quite the handful. So we'll see how far I get. I don't know if I'll get all the way through, but I am not leaving that numerator like that. Not a chance. Okay, I want a single function up top, not the product of 2. I'm going to multiply that 3 in so that my u, I can evaluate that directly. Right, I can do du right away. I can do dv right away. So calling it 3 minus 3 sine is a good idea. Otherwise, if you left it like that and you did du, you'd have to use the product rule on top as part of the quotient rule. Now, because one of your factors up top is just a constant, that means its derivative is 0 and things will cancel out a little bit for you, but I just don't want to have that. So my u is 3 minus 3 sine. My v is 2 cosine. So du is -3 cosine. And dv is -2 sine. Sorry, it's kind of messy. Way over here. All right. VD minus 2 cos theta times negative 3 cos theta minus u, that's 3 minus sine, times v all over 2 cosine of theta quantities. And simplify. Prayer, whatever you need, right? Yeah. Because the derivative of 3 is 0. And so I'm really just taking the derivative of that right there. Yeah, so negative 3. Yeah. Cool. So multiply it out. Negative 6 cosine squared. I'm going to get wild and crazy. I'm going to distribute and subtract. Whoa, I know. Live on the edge, Rosie. Plus 6 sine theta. Minus negative, right? And then minus 6 sine theta. Right, that should multiply like that. Denominator is just a monomial, so I will actually square it. 4 cosine. I can still simplify. I don't have to leave it like that. It's still ready, like factored in my mind. Now, if there were like terms, I would combine. But there aren't. So now, like if it was just algebraic, maybe factoring and simplifying would be nice. With trig, it's identities and simplifying that I'm trying to pin. But make sure you can get to here first. I don't think we're going to finish it today because we're approaching our 2-minute mark here. But I do see some things that I like. And to help you see them, I'm going to reorder this a little bit. I'm going to put it in standard form to help you see what I see. See anything? What do you see? So what I can do to make sure that I'm getting like the right sign and the right size is to try to isolate just cosine squared plus sine. Like just pick on that, make sure that I have those two set up right next to each other. So I'm going to factor out the negative 6 that's in my way, because now cosine squared plus sine squared are right next to each other. And hey, might as well just do it right now. I'll pull it out everywhere and just have negative sine of theta in there. I don't have to do that right away, but it's in common. Why not? Right? Make my life a little easier, hopefully. Because this right there is 1. So I'm left with negative 6 and then 1 minus sine theta. And you know what? Let's simplify though. Negative 6 on top, a 4 on bottom. Let's call that negative 3 over 2. Why not? We got constants. And that's not the easiest thing in the world to always know, to look for and see and do well. And so if that is like just not sitting well with you, like how am I supposed to know I'm gonna do that? I'm not gonna let a question like this keep you from an A on our quiz. Okay, or a B or whatever. I don't want that question to be the one that really holds you back. But that will get you to that point, and I'll tell you what, we're not done with this question. Well, we are done with it. Okay. Give it a shot. Yeah, see if you can get this done. Tonight, if you have some time, if that's not something that is realistic for you, We'll go over them in the morning, kind of fill in some gaps as you go, and then you can submit it. So I know we didn't quite have a lot of time, but if you have some time tonight to try it ahead of tomorrow, I think that would be good. But I do want to keep rolling through. Try if you have time tonight, see if you can finish. If you don't, then do it tomorrow. I'm not going to stress on it. No. You can still get full credit by getting it to me tomorrow. For sure. Thanks, everybody. Have a good day. I'm going to go over it in the morning. So, absolutely. It's like I would submit it tomorrow so that you have complete work to look back at. I'll probably even change the due date like on it till tomorrow so that it doesn't even show up late. Yeah. Yeah, that's fine.